Okay, thank you very much, and thank for our hosts. I'm very pleased to be here, first time at this institute, Vinča, and today I will present you the paper entitled "Evaluation of Gaseous Emission Characteristics During Forest Fuel Combustion in Masslow's Calorimeter coupled with FTIR apparatus." Authors, of course, by me, and co-authors by Milan Protic, Viša Tasić, and Aca Božilov. Of course, I also forgot to mention that I'm also coming from Faculty of Occupational Safety in Niš, University of Niš, and I'm there work as a teaching assistant. The influence of forest fires on the global composition of the atmosphere is well known, and especially its influence is much more pronounced at the beginning of the 21st century, with increasingly frequent occurrences of large-scale fires. In most cases, its dramatic impact on air quality is expressed in forest fires that last for tens of days. Due to the increased frequency, there is a need to monitor the parameters that contribute to ambient air pollution, which means improving the quantification of fire emissions. Emission gases from forest fires consist of a larger number of gases, aerosols, and particle matter. The most common are carbon dioxide and carbon monoxide, methane, and other volatile organic carbon compounds. This paper investigates the chemical composition of smoke during the combustion of terminal branches of Pinus sylvestris. The paper includes the research of the chemical structure of combustion products in laboratory conditions. Controlled combustion of Pinus sylvestris was performed in laboratory conditions using a Masslow's calorimeter, whose environment was further adapted to sample emission concentrations. Samples were exposed to heat flux of 50 kilowatts per square meters, and sampling was performed with the gas analyzer GASMET DX4000, which works on the principle of FTIR technology. The gas analyzer has a library of 16 different compounds, in addition to emission concentrations, flammability parameters, which were also measured and analyzed. Results shows the presence of water vapor, carbon dioxide, carbon monoxide, nitrogen oxides, ammonia, ethylene, and methane and ethylene concentrations. Compounds with concentrations below 10 ppm were not taken into further analysis. Measured concentrations were compared with heat release rate, mass loss rate, and in order to find the dynamics of generating the emission concentrations. Here also in the table you can see the flammability parameters which were obtained in the Masslow's calorimeter. During the tests, water vapor, carbon dioxide were released during the flaming and smoldering stage. Increased concentration of carbon monoxide, nitrogen oxides, ammonia, methane, and ethylene concentration were observed during the flaming stage. Dynamic combustion and gaseous emissions primarily depend on the chemical composition, physical structure, and the moisture content of the sample. This will be the short presentation. Actually, this is just demonstrations and presentation of a laboratory at the Faculty of Occupational Safety, Laboratory for Fire Protection. And if you have any additional questions, I'm here to answer here. Thank you very much for your attention.